Okay, so we don't usually do rectangular approximations for areas because we have sleek, shiny, modern calculus to do it, but they're asking us to approximate the signed area using left rectangular approximation with four rectangles. So, okay, we can do that. Left rectangular means it's the left edges of the rectangles that touch the curve. So if you were doing this area here, you'd have that rectangle and this one and that one. All of these rectangles have their left edges just running into f of x. So that's what we have to set up here. Now, they have us integrating from 0 to 4, as I've marked here, meaning we're going to get some positive and some negative area, and they know that. They mentioned signed area. And they want four rectangles, so at least we get nice round numbers there. Each of these rectangles will be 1 unit wide. They'll sit like that. So let's sketch these rectangles in, and then we'll figure out how big they are. The first rectangle will go from 0 to 1, and its left edge has to touch the curve, so it's going to be that big. The next rectangle goes from 1 to 2, and it has to touch the curve, so it's going to be that big. That corner is on the curve. Our next rectangle, see what's going to happen? This rectangle, this is a bit of a glitch, or this is a bug with the rectangular approximation. If you look right here at 2, the curve is right on the x-axis. It's having an x-intercept. So this rectangle is not going to have any height, and it's not going to have any area either. This is a bad thing that can happen with rectangular approximation, and it's not our fault, but it's probably going to screw up our answer rather badly because all this area is going to get overlooked. Will these other areas make up for it? Maybe. We'll see. But this is definitely a major source of error. And our final rectangle goes from 3 to 4, and its left edge has to hit the curve, so it's going to look something like that. Okay, so all these rectangles are 1 unit wide. That's nice, and we have it figured out already. What about their heights? The function they're running into is 4 minus x squared. Here, when x is 0, we get 4 minus 0 squared. So that rectangle is 4 units high. Where this rectangle starts, x is 1, so we get 4 minus 1 squared. So that rectangle is 3 units high. Here, when x is 2, we get 4 minus 2 squared is 0. So as previously mentioned, this rectangle is 0 units high. And when x is 3, we get 4 minus 3 squared is 4 minus 9 is negative 5. So this rectangle is 5 units high, or 5 units low if you want to be cute. It's got negative height. So if we do rectangular approximation, this first rectangle is 1 by 4. That's 4 units of area. The next rectangle is 1 by 3. That's 3 units of area. The next one doesn't have any area. And the last one is 1 by 5, so it's got negative 5 units of area. 4 plus 3 is 7. Take away 5 is, our rectangular approximation is 2. Okay, so if you just want the question done, it's now done, and you can move on. Just for grins, if you want to hang around, I'm going to check what the real area is, and we'll see how good this approximation was. The area for real is the integral from 0 to 4 of 4 minus x squared dx. And because they said signed area, I don't have to worry about breaking this into two pieces. The straight up integral will take positives here and negatives here and combine them, and that's what we want. So antiderivative for x minus 1/3 x cubed, evaluate at 4 and at 0. And so we get 4 times 4 is 16, minus 4 to the third is 64 divided by 3, minus, at 0 a wonderful thing happens. All those terms are 0, so we can just ignore that. And we get 16 is 48 over 3 minus 64 over 3. So it's negative 16 over 3, which is negative 5 and a third is the real area under, or the real signed area. So, did it hurt us missing all this negative area here? You bet it did. This came out to, oh, I'm sorry, that should be a -2. We got a total of -2 when the real total was -5 and a third, and almost certainly most of the blame falls on this rectangle that ended up missing a large amount of our negative areas. So using more rectangles can help, but there's some inherent weaknesses in the rectangle approach in that sometimes the heights, a 0 in the wrong place can mess with your answer pretty badly.